In this second and final part of the presentation and descriptive statistics, I'm going to show how to construct frequency distribution. And to do so, we're going to be using the same data set as used before, which is the return series for the Russell 2000 stock market index. So now, going down here to where we need to start doing the work, right here, I show you here the protocol for constructing your frequency distribution table, which I've already done right here. So to do so, we want to go to data, as you see right here. So we want to go to data, data analysis, and then we want to check histogram, which is already right there. Okay it, and then let's clear what was done before. So we start on a clean slate. So click right here while your cursor is blinking there. The input range is going to be right up here at the top. Right there. It's going to be the return series. And then for bin range, do nothing. Leave it alone. And that's where Excel is going to determine the optimal class intervals for the output. So check labels. Click here for output and then click right here. While your cursor is blinking there, let's go down to somewhere in the spreadsheet where you desire the output to be posted, like there. All right, and there's nothing else to do, so just click OK and you have it right here. So a couple of things. First off, what Excel gives you here, as you see here, these are the upper limits of each class interval. So Excel doesn't give you the lower limit of the interval and the upper limit of the interval. You just simply have these upper limits, which actually suffice for what we're about to do. Second is Excel gives it the generic title bin. Bin actually refers to the upper limits of the class interval for the variable that we're using, and we're using the variable return. So you can overtype it returns, as I've done right here. There is one final issue here. Excel gives the last upper limit here a non-numeric label, more, which means more than, in this example, 13.06%. So I'd like to replace it with a numeric value. That way it doesn't distort the frequency distributions that we're going to be constructing. So to do so, first notice that these upper limits actually are separated by the same width. All right, so the gap between adjacent values are going to be identical. And to verify that, let's come out right there, hit equal, click on this, minus the lower value on top of it, and that's 2.1%. So if I copy down, you see it's the same thing. Therefore, what I do is to replace this guy right here with a value that matches with the same gap width. So I'm going to hit equal, click the value on top, and then add the width. All right, so that's 15.20%. Now though, it is a calculated value, as you can see right here, as opposed to if I click on any of these, you can see up there these are straight values. So we don't want this to be calculated. So to make it show as a straight value, let's go home here and copy it and then paste it upon itself by going to paste special. So click on this down arrow right here and choose paste value. All right, and now you see it, it's a value, and that's all that you need to do. Now then, we're ready to go ahead and construct our cumulative frequency, relative frequency, and cumulative relative frequency, because all Excel gives you, as you can see right here, are just the basic frequency table. But no worries, because all we have to do here, if I clean out what I did before, I come out there for cumulative frequency, click on this guy right here, the first observation, and then for the next one is going to be what you have already plus what you currently have, this guy right here, because cumulative frequencies are running totals. So then you work your way down, and as you can see, the final running total is equal to the sample size of 357. Relative frequency are going to be the percentage values of each of these frequencies. So sitting right here, hit equal, click on this frequency divided by the total being 357, and enter. Now then, copy down, but before you do so, keep in mind that the denominator, the total, needs to be a constant. We don't want it to move around. So click over it right here and then click the function key F4 on the keyboard to place these dollar signs around it, and then hit enter. All right, that way it registers. Now I copy down. And as you can see, it's going to be, the denominator is going to be the same for all of these cells. All right, finally, cumulative relative frequency, which is going to be the running totals of the relative frequencies. The first one there, the second one is going to be what's on top plus what's current. And that's it. And then copy down. And as you can see, the final value is going to have to be 1, which is the sum of all the fractional values. So now let's go ahead and construct the frequency histogram, which is a bar chart of either the frequency or the relative frequency. You can choose either of the two. So I'm going to kill this first so as to not confuse anyone. All right, so now coming out here, I'm going to highlight these two columns. Now in constructing your distributions, Excel recognizes XY protocol, meaning the first column is X, the second column is Y, and Y is what we want to construct, the frequencies. If this guy here were to be a couple of columns away, then we're not going to be able to do that, and I'll show you how to get around that. But for now, the two happen to be next to each other. So with this, we go to insert, and then we have two choices. We can use recommended charts, and I'll get to it shortly, or we can do things the old school way. Now, frequency histogram is a bar chart, so I'm going to click this first option here and choose any of these bars. The first one is quite okay. Now then, so right here, we need to clean this up. We don't need a chart title. So right here, as you can see, Excel constructs both columns, returns and frequencies. Returns, actually you won't see them, but you might see them a little bit. They're in blue. And then frequency is actually what we want to construct. So we need to remove returns so as to delineate what we want to see, frequencies. To do so, right click anywhere on the graph. Right click again, and then go to select data, and then click on returns and remove it. Now we have only frequencies, all right, as you can see. Now secondly, observe that the x-axis actually are logical values. Excel doesn't quite give it what it should have, which are the returns values. You can see here, these are really logical labels. So to change it, click edit, and then click on this first value for returns and go all the way down to the last one on the table and click OK, and click OK, and you already see it right here. Finally, these bars need to connect. So right click on any of the bars, any of them. Right click on any of them and click Format Data. Now you see gap width, it needs to be 0. So move this needle to the left until you see 0, and voila, as you can see. And you can see my finished product right here. Now the other way that you could do this is when you highlight these two columns right here, right, you go to insert, you can use recommended charts, and one of them is bound to be what you want, which is the second one right here, and OK it, and you're done. All right, so you can go ahead and right click on any of the bars and click Format Data Series and move gap width to 0, and c'est fini. Alright, so the next thing we want to do is to construct frequency polygon. Frequency polygon is a line graph of the frequencies or the relative frequencies. Now then, before I construct that, keep in mind, going back here to the frequency histogram, here we constructed it using frequencies, but we can also do the same with relative frequency. The shape of the bars is going to be the same. All you have to do while clicking on this graph, go here, take your cursor, go to the edge of this column until you see what looks like an orthodox cross. Click, hold, and drag it to the column you want. And you can see the shape of the graph looks the same. It's just that the values on the y-axis now reflect relative frequencies. Alright, so you can use this or you can use this to construct the frequency histogram. So now, going back to the polygon, which is a line graph of the frequencies, go here, insert, and here we're going to choose this this one right here because these are all lines. So click on it and choose the first one. And again, Excel gives you lines for both returns and frequencies. We do want only for frequency. So again, right click, select data, click on returns and remove it. And for the x-axis, click right here and up over here, highlight all of these. And you can see it registers. OK. And OK. Now we're good. So once again, this can be accomplished using either frequencies as I've shown or relative frequency. To do so, if you want to use relative frequency, again, what you do is come and drag this. When you see the Greek Orthodox type of cross, click, hold over here. You see the shape of the graph is the same. The limits are different. The values up here are different. But so you can use either frequency or a relative frequency to construct the line graph called a polygon. Before we get out of this zone here, observe that this clearly delineates what we observed in the first part of this presentation for this because this distribution is skewed to the left. As you can see, the mass of the distribution is right here on the right. So as you can see here, the likelihood that you're going to find larger values are far greater than finding lower values up here because the peakness is toward the left, toward the larger values. All right, finally, we do want to construct the ogive, all right, which I show right here. The ogive is a graph of the cumulative frequency or the cumulative relative frequency. So to construct the ogive, you could do this real quickly for yourself. If you click on this graph right here, why don't you do what I just explained to you? Move this guy right here. That's your ogive based on cumulative relative frequency. Or you can use cumulative frequency. Drag it over here. That still is your ogive using cumulative frequency. So now, finally, a couple of nice touches. This tells you to plot the price series, which I've done here. To plot the price series is it's not such a big deal. The price series is this guy right here. So highlight these two columns, all right, and go to Insert. And if you want to, you can use Recommended Chart and choose this right here. That's your price series, right? And you have it right here. And that's what I give you right here. And it says, what can you say about the performance of the stock market of the sample period? A couple of things I wrote out here for you on this example, but observe right here. What you see right here, that's the hiccup that occurred during the 2008 global financial crisis. It's quite a hiccup. And finally it says plot the return series. And if you want to plot the return series, so as you can see, to plot the return series means we're going to have to plot return against the date. But that might be an issue. So because returns is one column away from the x-axis. So what I do is I highlight these first two, all right, which we've already constructed right here. But if I highlight these two and go to Insert and go to the line graph right there, all I have to do, I think you already know what I'm about to do, grab this guy right here and move it aside. And that's your return series right there. And voila, right here. So, and it says, what can you say about the distribution of stock returns of the sample period? So this is just a little bit of a way of qualifying the nature of what you've constructed. And one of the things I note here is you can see what in finance we call volatility clustering, which is you can see that the zigzagging occurs are clustered around a certain date. Over here and over here. Over here, if you look at the dates carefully, you'll find that that occurred during the dot-com bubble and the 9/11 era recession that came in its wake. So we saw a lot of clustering of stock returns volatility, as well as in the period surrounding the 2008 global financial crisis. A phenomenon which in finance we refer to as generalized autoregressive conditional heteroscedasticity, or GARCH. If you want to learn more, read up this little narrative here, or you can also go to Google if you want to. But I hope you enjoy this presentation. Let's keep learning.